Hello, today we'll be looking at the 2010 AP Calculus BC free response question number 5. The most important thing to note is what is given. So we have a differential equation, an initial condition, and another statement which you can use to check. These will all be used first as an Euler's method, then as a limit, and then as separation of variables to find a particular solution.
Okay, so now we're going to solve part A. So I copied down the question once again, just for reminder's sake, and also remember the initial condition given. F of 1 is equal to 0, and dy dx is equal to 1 minus y, where y equals f of x. So, as I noted before, this is going to be an Euler's method problem, and so we will do that. So first, set up x minus 1 is equal to y minus 0. That is just plugging in the points at which we're starting. And then you have to take the derivative at 1, 0, and using this initial condition, dy dx equals 1 minus y, we find that the slope at this point is 1. So we put that in. We plug in 1/2 because it's two equal step sizes going towards 0. So we go back 1/2 and y minus 0 on the other side, and then using simple algebra, we find that y equals negative 1/2 after one step. The second step, we do the same thing. Now we are at 1/2, and y is at negative 1/2. The derivative at this point will lead to 3/2, so the slope is 3/2. We plug in 0 now because we're on the second step, is equal to y plus 1/2, and then we just multiply these together, add, move to the other side, and we get y equals negative 5/4. Thus, using two equal step sizes with Euler's method, we approximate that f of 0 is equal to negative 5/4. So the first point is assigned for using two equal sized steps with Euler's method, and then the final point is to get the actual answer. So whenever you see an Euler's method problem, set up whatever they give you, 2 steps, 3 steps, whatever it is, and even if you don't know how to get the final answer, with a bit of luck, you will be able to at least get the first point.
The second part of this question, part B, is the limit as x approaches 1 of f of x divided by x to the third minus 1, and once again, show all work that leads to the answer in order to receive full credit.
So now we'll be solving for part B, which is the limit as x approaches 1 of f of x divided by x to the third minus 1. Please show all work, and remember the initial condition. F of 1 is equal to 0, and dy dx is equal to 1 minus y, and another way of writing that is f prime of x. So we have the limit, and as soon as we look at the bottom, we see that the limit as x approaches 1 of x to the third minus 1 will yield 0. As soon as you see this, it should indicate that maybe L'Hopital's will be applied, so we check. The top, when you do the limit as x approaches 1 of f of x, that will yield f of 1, which, according to the initial condition, is 0. Then we show again that the bottom will also yield 0, and therefore we have a 0 over 0 case, in which L'Hopital's rule can be applied. So this is a symbol here with a capital H with inside of a circle. This will indicate to the reader that you have just used L'Hopital's. So take the derivative of the upper part and then separately the lower part. A very common mistake is to take the derivative of it as a whole as if it was a quotient rule, but do not, because that is not what it is according to L'Hopital's rule. And always keep the limit in front. So we have the limit as x approaches 1 of f prime of x, or dy dx, divided by 3x squared. So, as we know, dy dx is 1 minus y, and thus we have 1 minus y, or f of 1, because we're plugging in 1, and the bottom, equally, we plug in 1. And we know, once again, using the initial condition, that f of 1 is equal to 0, so we get 1 minus 0 over 3, which equals 1/3. So where are the points given in this problem? The first point given is to show that you are using L'Hopital's rule and to prove it. College Board has become very rigorous on proofs, and especially showing that you are using L'Hopital's, you must show that both go either to 0 or infinity, negative infinity. The second point is given for actually getting the answer 1/3. So once again, if you see this but are unable to get the answer point because you do not know how, at least try to do something like L'Hopital's, and if you are, prove it very rigorously in order to get that first point.
The third and final part of this question is to find the particular solution y equals f of x to the differential equation dy dx equals 1 minus y with the initial condition f of 1 equals 0.
So the third and final part of question 5 is to find the particular solution y equals f of x to the differential equation dy dx equals 1 minus y with the initial condition f of 1 equals 0. So the first step is to cross multiply, and you get 1 minus y dx is equal to 1 dy, but as you can note, the y and the dx are together, so this does not work. We divide both sides by 1 minus y, brings it over to this side, and we get 1 dx is equal to 1 divided by 1 minus y dy. So now we have to integrate. So we integrate both sides, and we get x plus c. So c is one of the most important and, if missed, costly errors you can make on this type of problem. And then, so on the other side, we have negative ln of absolute value, once again, very important to keep, of 1 minus y. So we're going to find c. So how do we find c? We just have to use the equation we just got, and with the initial condition, f of 1 equals 0. So x is plugged in, is changed for 1, y is changed for 0, and we get 1 plus c is equal to negative ln of absolute value of 1 minus 0, which is just 0. So we get 1 plus c equals 0, thus c is equal to negative 1. So we plug in that negative 1 to c, move over the negative, and we get negative, absolute in parentheses, x minus 1 is equal to ln of absolute value of 1 minus y. So now both sides become e to the power, and the absolute value will go away and transform into plus or minus on the other side. So we get plus or minus e to the negative x plus 1 is equal to 1 minus y. So now we have to find whether it is plus or minus. So once again, we'll use the initial condition with our equation, plus or minus e to the power of negative 1 plus 1 is equal to 1 minus 0, which e to the power of 0 is just 1, so we get plus or minus 1 is equal to 1. And obviously we don't need a negative, so we just have a plus. So now we go over here, and we solve for y. We move it over to this side, the e to this side, and we get y is equal to 1 minus e to the negative x plus 1, which, if you would like to rewrite it, you get 1 minus e to the 1 minus x. So where are the points distributed? The first point is assigned to separating the variables correctly, into which you have the y with dy and 1 with dx. Next, you get a point for integrating both sides correctly, where you get here. The third point is assigned for finding c. So if you don't find c or don't think of c, you will at best get 2 points, which are the first two, but you cannot get any subsequent points. So we found c, and that's another point. That's the third out of 5 points. And then, so this point is assigned more generally for the use of an initial condition, which is finding whether it is a plus or a minus, and c. And then the very final point is solving for y and getting this correct equation. Now, the worst possible case scenario is if the variables are not separated at all, then 0 out of 5 points will be awarded to the problem, even if every subsequent step is done correctly. Thank you for your attention today, and I hope that was useful and helpful to see not only a more in-depth analysis of how these FRQ questions are scored, where the points are assigned, and also specifically how to do this question. And I hope this will be able to help you out if, for example, you don't know how to do a question just to get the maximum amount of the points assigned. And I hope you'll have a good day. Thank you very much.